Here we go again. In this optimization problem, we're going to look at the sum of two numbers is equal to 10. And what is their smallest their product can be if both numbers are bigger than or equal to 1. First, we're going to look at the sum of the two numbers is equal to 10. So we're going to arbitrarily choose the variable x and y and set it equal to 10. Then we're going to solve it into the slope-intercept form. Y is equal to negative x plus 10, just so we have a nice way to see the equation. We can sketch out a graph, just so we have a simple visual aid to guide us. We have a y-intercept of 10, a x-intercept of 10, and a graph with a negative slope. Next, we'll look at if both the numbers are bigger than or equal to 1. We're going to set x is greater than or equal to 1, and we're going to set y is greater than or equal to 1. In the graph, we will have a vertical line at x is 1 shaded to the right and to represent x is greater than or equal to 1. We'll have a horizontal line shaded above to represent y is greater than or equal to 1. Visually, we can start seeing possible optimization values. One at 1, 9, and another one at 9, 1. We will keep these in mind as we continue doing the problem. Lastly, we'll look at the line, what is the smallest their product can be? So we're going to set x times y is less than or equal to the smallest possible value. And we're going to set the smallest possible value to some arbitrary function z. So that we will have z is equal to x times the substitution of y, which is going to be minus x plus 10. We're going to perform the derivative with respect of x to z and set it equal to 0 to find possible maximums and possible minimums. So we'll need to take our z function and distribute dx so that we don't have to do the product rule when taking the derivative. We end up with negative x squared plus 10x. Time to take the derivative and set dE equal to 0. So we have 0 is equal to minus 2x plus 10. And we're going to solve for x by adding 2x to both sides. So 2x equals to 10. Then divide by 2. So we have x is equal to 5. Remember above that we have y is equal to negative x plus 10. We'll substitute in the value of x and solve for y. So we'll have y is equal to negative 5 plus 10. And then we'll have y is equal to 5. So this lets us know our next possible solution, x comma y, will be 5 comma 5. Let's look at the order pairs we have. Previously, we had the order pairs 1 comma 9 and 9 comma 1. We just recently found a new order pair, 5 comma 5, in order to figure out what our smallest possible product can be. However, what about the parabola z equals negative x squared plus 10x? Well, if we extend out our graph of the parabola and stated our vertex value of 5 comma 25, this is clearly outside the original equation where the sum of the two values have to be equal to 10. Time to check our order pairs. We're going to first look at our order pairs 1, 9 and 9, 1. If x is equal to 1, then we'll have y is equal to 9. Or if x is equal to 9, then we will have y is equal to 1. In either case, if we have 1 times 9 or 9 times 1, we still get the product of 9. Next up, we're going to check 5, 5. We're going to have x is equal to 5 and y is equal to 5, so that we have the product of 5 times 5, which is equal to 25. So we can clearly see 9 is less than 25. So we can conclude that the product we're looking for is 9. Huzzah! We did it! We found the smallest product of two numbers whose sum is equal to 10, and both their numbers are greater than or equal to 1.